Hello friends, today we are going to talk about how exactly your computer works, how the instructions are executed in detail. So our today's topic is top level view of computer function and interconnection. So basically there are main four components of your computer. Here we have listed them. See, first one is data and instructions are stored in a single read-write memory. So memory is one of your components. The contents of this memory are addressable by location without regard to the type of data contained there. Memory is one of the components. Other components are your CPU, your input and your input-output devices, and the bus which connects all these three components to each other. These are main components. And execution occurs in sequential fashion from one instruction to the next. If there is particular computation to be performed, a configuration of logic components designed specifically for that computation could be constructed. Now, we are going to talk about how exactly the computers can be developed, how exactly the components are developed. Okay, look at this diagram. How programming in hardware can be done. See, if you want some particular task to be done, you can create some kind of hardware for certain particular task. And when you provide data for to that hardware, that will process the data in same way always, and it will produce the results. Okay. So in this case, you are just performing a single task. Okay, and this is actually your hardware, and it is sequence of arithmetic and logic function. It will always perform the same functions and uh, same arithmetic and logic functions to your supplied data, and it will provide results. So if you want another task to be done, different task, then you have to again rewire your hardware, right? So this is the limitation of your hardware. Every time you want certain different tasks to be done, you have to create a new hardware. Okay, that's why it is important to uh, uh, to control this hardware by using a certain kind of software. Okay, and that's why we have divided this one part into two parts. Okay, now see, what we are saying is we are going to supply instruction codes, and there will be one instruction interpreter, and instruction interpreter will generate control signals, and according to these control signals the functions will be arranged, and then you will get the result. Okay, so what we have done here is, if you change this part, instructions codes, then the interpretation of those instructions will be different. Different control signals will be generated, and this is how you can perform any task without changing the hardware. Okay, you can also supply different kinds of data, and you will get different results. So in this case, you don't have to change your hardware every time you want your computer to perform a certain new task. Okay, that's why this is called a software approach, and this is very important. Now we are going to talk about how exactly these instructions are provided, and how these instructions are interpreted, and how control signals are generated. And this part, the instruction interpretation and the control signals and this arithmetic and logic sequence of arithmetic and logic function, this all happens in your CPU. This is called as your CPU, and this set of instructions codes, this will be called as your software. Okay. And for supplying data you need your input devices, and for getting the results you need your output devices. And as you can see these arrows, we are sending data from one component to another component, and for this we need a bus, which the bus will carry data from one component to another component. Okay, so this is the difference between hardware approach and software approach. Now let's see the basic structure of your computer, uh, your processor actually, which registers are there, and what are the functions of your register. See, this is your main memory, this is your system bus, this is your CPU, and this is your IO module. Okay, see, as we have discussed four components, there are four components. See, in main memory, your data and your instructions are stored. Okay, when you and these instructions are fetched from your main memory into your CPU. When the instruction is fetched, it is stored in your instruction register. And this PC is called as program counter. It contains the address of your next instruction, the next instruction which has to be fetched. So it is generally, you just have to increment this if in case of sequential instructions. If there is some kind of branch instruction, then and then only you need to this contents of this PC will have to be calculated. I mean, if you have to check some condition, then you are going to uh, execute certain set of instructions. If the condition is false, then you are going to execute different set of instructions. That's why in that case, in branch instruction case only, you have to think, you cannot calculate, you cannot increment the contents of PC, you have to calculate the contents of PC, and then you can fetch the next instruction. Okay, so up until now we have discussed that when you fetch one instruction from your memory, it comes here in instruction register. Okay, uh, we'll study what is the format of your instruction in our next part. But when this instruction is stored here, instruction has again two parts. One part is your instruction, it's opcode actually, what operation has to be done. And in second part, it has the data or the address of data. Okay, if this instruction has address of data, then the address will be stored here, memory address register, and from by using this address the data can be fetched from your memory. Okay, and this MBR is your memory buffer register. It stores the fetched data. When the data is fetched from your memory into CPU, it will come here in memory buffer register. And even if you want to store some data, some result into your main memory, in that case also the result is stored in your MBR. Okay, here is your execution unit. Again, we have two remaining registers, IO AR and IO BR. IO input output address register, input output buffer register. These two again work same as memory address register and memory buffer register. The only thing remain different is these this address will be related to this module in IO module, and the IO buffer register will store the data which is fetched from your IO module. Okay, here all the execution of instructions will be done, and after execution is done, the result will be stored in MBR before it is copied to your main memory, and before it is sent to your output module. I hope that is clear. Now, let's see what is a basic instruction cycle. See, when we are talking about an instruction cycle, it is depending it consists of these phases: fetch instruction and execute instruction. Okay, these are basic two steps in any instruction execution, but every instruction has to go through these phases, and that's why it is called as instruction cycle. So after starting, first instruction will be fetched from your memory. That instruction will be executed. It will check whether it is last instruction. If it is not, then again it will fetch next instruction, and this cycle will continue until your last instruction comes, and then the program will halt. That is, it will be stopped. When we are talking about instruction execution, this is going to have again different parts according to the type of instruction. Based on your type of instruction, different actions may be taken. See, first one is processor to memory. Data can be transferred from processor to memory or from memory to processor, or it can be transferred from processor to IO module or from IO module to processor. Data processing can be involved. The processor may perform some arithmetic or logic operation on data. And last, if your instruction is of control type, then the instruction may specify that the sequence of execution be altered. So in control instructions, the branch instructions will be included. Okay, I just told you that we'll study what is the instruction format. So this is how the instruction format looks like. We'll study the example in our next lecture, but let's just think about how the instruction format is there. See, this is your opcode. This is actually a 16-bit word we are considering, and in 16 bits we have allocated 4 bits for your opcode and remaining 12 bits for the address, for specifying the address in your memory. And this is your integer format. This bit will specify the sign of your integer, and this will specify the value of integer. Okay, now we have already studied these two registers, and there is also accumulator. It is temporary storage. It is also used while performing different tasks. We'll study use of these registers by using one example, but in our next lecture. And see, this is a partial list of your opcodes, and I want you to note that, see, if you have 4 bits, then just think about how many different combinations can be there. There are actually only 2 bits, okay, 0 and 1. And for 0 and 1, you need to think about for 4 bits, how many different combinations will be there. So it will be 2 raised to 4. That means that will be 16. So you can have 16 different instructions for this type of instruction format. And you can specify 16 different types of operations by using 4 bits. So since 0001 will be load AC from memory. 0010 will be store AC to memory. If the opcode is 0101, then it will be add to AC from memory. So this is just a partial list of opcodes. Uh, this list of these opcodes and this its interpretation is actually stored in your instruction set. Okay, so your computer will know if the opcode is this, you have to perform this operation. If opcode is this, you have to perform this operation. Okay, we'll study this in detail by using an example in our next lecture. Let's just stop today for here. Thank you.